Now, what are some of the factors which have brought about or accompanied the really fantastic efflorescence of chemistry in the last 40 years? There are many. I would start with what you might express in a single word: rationalization. That is, the bringing of theory, most broadly defined, into practice. What that amounts to, you might say, is extension of the conceptual schemes which chemists use and their application to real experimental cases. And that's going on. It has facilitated the work of the chemist a great deal, and it continues to expand and to make the science a more powerful one. In addition to these, what you might loosely call theoretical developments, there have been developments on the experimental side of very great importance. One of those is the introduction of physical methods of all kinds into chemistry. You will observe that I'm concentrating on organic chemistry. That is perhaps not unconnected with the fact that I know a bit more about organic chemistry than some of the other branches. In organic chemistry, certainly, the use of physical methods has led to a tremendous increase in the power of the organic chemist to accomplish objectives of all kinds. Just to give a rough list, we can take ultraviolet and visible spectroscopy, infrared spectroscopy, nuclear magnetic resonance spectroscopy, and then, of course, the ultimate method, X-ray crystallography. In many of these areas, this department has played a major role in bringing these things into everyday use, and I think we can feel very pleased about that. And the situation really has changed fabulously. Some of those working with me right now, as it happens in the last few weeks, have by chance asked me what chemistry was like in the old days. And really, you know, they can't believe what it was like when I, for example, began. Just take a couple of contrasting examples. The determination of the structure of strychnine involved work by many groups, two extremely active ones, over a period of 50 years. It would certainly be a problem which would be solved now in a matter of days, without any question whatsoever. I'll tell a story from my own past about the synthesis of quinine. Now, this is perhaps a bit of fun because Max Tischler is here. When we were attempting to synthesize quinine, we had one step which involved an elimination of a quaternary ammonium nitrogen to give a double bond. And that double bond might a priori have been in either of two positions. One of them would have been an ethylidene position, the other would have been a vinyl position. We wanted the vinyl position. The analogies which presented themselves suggested that we had the vinyl compound. But how did we know? How could we tell? Any student today would give us the answer to that question in not days, but seconds. So easy, in any number of ways. In those days, there was only one way. Do a Kuhn C-methyl analysis. Oxidize it with chromic acid and determine the acetic acid that's formed if it's the ethylidene compound. What a cumbersome way. And in this department, we didn't have the facilities to do it. So I sent it to Max, and he came back and it said, 1 acetic acid, the ethylidene compound. What we wanted was the vinyl compound, and we spent a couple of very, very unhappy weeks until Max wrote us and told us that Merck had made a mistake. They'd got some nitric acid there instead of acetic acid, and it was the vinyl compound. So we were happy again. But just think of the contrast between those days and now. Bill Lipscomb told us of how extremely powerful demonstrated to us how extremely powerful X-ray methods are. And of course, he's played a great role in making them more and more powerful. They are, in the organic chemistry of the kind that I do, now the ultimate weapon, because they don't involve arguments. Once you have the X-ray crystallographic structure, you know it. You don't have to argue that the coupling constant is this or something or what have you. And that is a relatively recent development. I made a wager with Linus Pauling in the early 1950s that I would determine the structure of terramycin by chemical methods before anyone would do it by crystallographic methods. Now, I won the wager, but in making it, and by the way, it may appear that I make wagers casually, but I don't. I knew perfectly well that if I won that wager, it would be the last one of that sort that I would win. It was perfectly obvious even then that X-ray methods would achieve the status that they now have. They're an extremely powerful weapon. Let me give you just one other example of how the methods have advanced. Just a short while ago, we were able to get a C13, natural abundance C13 spectrum on 1 milligram of totally synthetic vitamin B12. It has a molecular weight of about 1,500, I suppose. It took 995,000 transients collected over a period of 4 days. Now just think of the stability of that machine that can do that, accomplish that task. So we have these fantastic physical methods available to us, which enable us to do in the twinkling of an eye things that would before have taken many years. And then in the third group, I'll put separation methods. We have now tremendously powerful separation methods which enable us, above all, to carry out reactions on a relatively small scale and still to know what we're doing to separate the components of any reaction mixture, and then use these physical methods to find out what those components are. So these extremely powerful separation methods have made it possible to do just incomparably more than we could do in the old days. There again, I'll just tell a story to liven things up a bit. Some of our early work was on the substance cantharidine. Now, that's the active principle of the so-called Spanish fly. Now, people have been working on that for many years, on cantharidine. And then when we looked at the old literature, we would find that people had taken 75 grams of cantharidine, 500 grams of cantharidine, boiled it with hydrobromic acid in order to see what products were formed in an attempt to determine what the structure was. Just think of it, 500 grams of cantharidine. There are many people who would think that would be an absolute tragedy. Realize that would be enough to keep the entire population of Spain in a state of quasi-erotic excitement for a period of a full year. Here they're boiling it up with hydrobromic acid. Well, you see, you don't have to do that now. You could do it on a couple of milligrams of cantharidine and find out everything that they found out from the 500 grams. Look, this has been a lot of fun, but Dudley said he wanted to do something at 5:30, and it's 20 to 6. Thanks a lot.